So good morning, everyone. I am Nicolas Michelet, and will present you the results of the ANODE project of France Energy Mine, which is a collaborative project with all the partners you can see on the bottom left of this slide. So first of all, what is the ANODE project? A lot of questions about the environmental impact of galvanic anode was reported by the civil society in France. And we have an example here on the slide, an article of a journal which speaks about a fish contaminated by aluminium. So France Energy Mine proposed a collaborative project to answer what is the potential impact of the galvanic anodes on the environment, which is performed with first, some bibliographic review, the selection of the study sites, the numerical modeling I will present you today, and an ecotoxicologic analysis. Here I will present you the numerical modeling on the Courseulles-sur-mer site. This site, which is located on the north coast of France, in the English Channel. We have performed numerical modeling to know what the dispersion of the heavy metal coming from the galvanic anode will be. So we have introduced some forcing into the model. We have the tidal 13 tidal harmonics. We have the wind and the thermal fluxes influence coming from a model from Météo France, and also the influence of 9 rivers in the domain. And in particular, we have here on the image the Seine River. I will not present you today the validation, but just to let you know that we have validated the configuration with 2 tidal gauges here. One in Le Havre Harbor and another one close to the mouth of the Seine River. And we have also validated the variation of the temperature and salinity of the water, which could influence the dispersion of the metal in the domain. However, we don't validate the dispersion itself because of the lack of data, which is one of the first recommendations coming out from the project. This simulation was performed for 5 years, from 2013 to 2017 included. To model the release of the heavy metals coming from the anode, we have modeled every wind turbine of the Courseulles-sur-mer site. Here you have the delimitation of the park, and each spot represents 1 turbine. So this is the old configuration with a 75 wind turbine. And we have estimated that at each point, every time step of the model, so every 30 seconds, the 15 tons of anode which planned to be installed on each wind turbine would release, for example, 455 milligrams of aluminium. So every time step at each point, we diluted this mass of each metal into the domain. So here I will present you a little video which show you the dispersion. I hope it will be okay for you. You will see what's going on. So you can see the aluminium dispersion here. We can see that most of it is advected through the southwest along the coast, which is consistent with the residual currents known in the area, and along the coast, and coming out of through the western boundary here. And the residual currents show us that every metal that will go out through the boundary would be re-injected into the English Channel through the north, and will not coming back to this area. So we have considered that every aluminum coming out of this boundary is deleted from the simulation. Sorry. Okay. So what do we how do we consider the toxicity of each metal? First, for each of them, we have considered that they are entirely dissolved into the water column to be the most bioavailable for each species, which give us highly protective results. We compare the results of the simulation to the predicted no-effect concentration, also known as the PNEC, and for all metals. For the aluminium, we have written two PNEC, one coming from Crane et al. 2007, which is 0.005 microgram per liter. So this is the toxicity threshold. However, it considers only the aluminium isomeric monomeric, so it's just a small part of the total dissolved aluminium into the water. And we have considered another PNEC equal to 24 microgram per liter, coming from another article, which consider all the dissolved aluminium into the water. However, based on the Klimisch criteria, which is a criteria which told us that both PNECs are not fully satisfying and need more investigation. However, we just have this data available, so we have to run our analysis with these two thresholds. For the other metal, we have silicon into the anodes considered. However, no toxicity thresholds are known, so we cannot perform the toxicity analysis. And for the other metals, we have reliable PNEC. Here you have the concentration of aluminium concentration, the median value founded during this 5 years of the simulation. We can see, as I described earlier, that the aluminium is advected through the southwest along the coast and will go out through the western boundary. The median value exceeds the first threshold of 0.005 microgram per liter over the entire Seine Bay. However, the second one is never exceeded during the 5 years of the simulation. What if we look at the 4 points in this domain? First of all, this is a 3-dimension simulation. So if we look at the aluminium concentration along the water column, we can see that at each spot we have almost constant concentration. So we will look only what happened close to the bed, which is the location of the anode on the pile of the wind turbine. If we look at each location, the temporal variation of the concentration of aluminium, we can see that close to the park, P1, P2, and P3, we have a very high variability of this concentration, which stay close to the median value, of course, but we can have some peak of 20, 30 days showing much more higher concentration compared to the median value. However, at the last location, P4, which is more far from the park, we can see a slow variation of the aluminium concentration and even some months, because here you can see on the beginning of the third year, we have almost 3 months with no aluminium at this location for this location. So we have to consider what is the maximum short exposure, so the short time exposure and the long time exposure, because we have some species who just passing through this location and others who just live in at those locations. If we look close to the park, so the first three points, what is the maximal short time exposure on 2 days, we can see value around 0.8 microgram per liter. And if we look at the long time exposure at the same location, we can see that it decreased a lot, as you can see with those value close to 0.5 approximately. On the fourth location, the short exposure show a value of 0.4 microgram per liter, while a long exposure is close with 0.3. All these numbers does not necessarily mean something for you. So here is some number to compare with. We have seen in an article, Gabel et al. 2012, that he has a measure in the Seine estuary, so very close to the park, concentration of aluminium between 25 and 70 microgram per liter. So you can see that it's almost 100 times what the anode release. And Angel et al. In 2015 have reported some measurements into the North Sea, close to the English coast, in natural coastal waters, between 0.5 and 2 microgram per liters. So naturally, the concentration of aluminium is higher than the what the anode release. So if we take a closer look to this value of the Seine estuary, we have performed two simulation, one considering a constant release of 25 microgram per liter of aluminium coming from the Seine, and another one with a constant release of 70 microgram per liter. And if we look here, you have the maximum concentration found during the 5 years of simulation. You can see over the park area, we have between 2 and 10 microgram per liter of aluminium concentration, just because of the Seine release, which is much more higher than the anode release. To finish and to conclude this presentation, what about the other metals? As I said before, for the silicon, we don't have any threshold, so we can't conclude on this metal. However, for the others, you have here on the second column of this table the maximal concentration reached by each metal. So this is the maximal we have seen during the 5 years of the simulation. You have the toxicity threshold and what represent this concentration compared to the threshold in percentage. You can see for the zinc, it's almost 2.3%. And for the others, even for the cadmium, for example, it is less than 0.1%. So it's very far from the threshold. And we can say that it's not necessarily a problem for the environment. So thank you for your attention, and thank you.